Hi everyone, this is Dr. Nak, and we're going to go over a little bit of partial fraction decomposition. This is just a short lecture on it. So step number one, what you need to do is you need to factor out the denominators completely until you cannot factor anymore. Then after you're done, you need to look at the denominators very carefully, and there are 4 cases. So the easiest case scenario is the denominator has non-repeated linear factors. Linear factors means that it's a degree 1 polynomial. Now, before I go over this, let's go over the general form of the polynomial all the way up to a degree of 3. So let me just write it over here. If it's a degree 1 polynomial, the general form is going to look like what? F of x equals ax plus b, and then because there's degree 1 there, and then degree 2 would be f of x equals ax squared plus bx plus c, and then degree 3 it's going to look like ax to the third plus bx squared plus cx and then plus d, and the degree 0 will be just a constant term. So f of x equals just a constant. Let's just call it a. Okay, so let's look at case 1. That little example that I wrote is 5 over x plus 1 times x minus 3. Now they are both linear factors and they're not repeated. Repeated means you're going to have an exponent on x plus 1 or x minus 3. But anyways, first step is this: determine how many partial fraction that you're going to get. So what determines that is the outer exponent on the parentheses. So here, x plus 1, you have to the first power. X minus 3 has first power. Add those two, you're going to get 2. 1 plus 1 is 2. So step number 1, just break it up into 2 little pieces. All right, now what goes on the numerator, what goes on top, is the general form of the polynomial of 1 degree less than what you're given in the denominator. So meaning, right now, the denominator, x plus 1, x minus 3, they're degree 1 polynomials. So what is 1 degree less? That will be degree 0, and that's nothing but a constant. So what goes on top is just constant a and then plus constant b. Okay, now let's take a look at another one then. So if I have like maybe x squared plus 1 all over, I'm going to make it up, x plus 1, x minus 3, and then x plus 4, something like that. Now let's determine how many partial fractions that we're going to get. What determines that is the exponent on the outside of the parentheses. So you got 1, 1, 1. So 1 plus 1 plus 1, that's 3. So for sure you're going to have 3 fractions. Now what goes on the bottom is just x plus 1, x minus 3, and then x plus 4. All right, now what goes on the top is the general form of the polynomial. So this is our general form of polynomial. All right, so on the denominator right now you're given degree 1, so 1 degree less will be constant. So here you're going to have a, same thing, b, and then c. So that will be the easiest case scenario. Now let's go with case 2. The denominator has repeated linear factors, so I'm going to make it kind of look like what we just did with case 1. So suppose we have maybe like 5 over x plus 1 squared and then x minus 3 to the, I don't know, pick a number, any number, I'll just keep it as 1. Okay, so first step, determine how many partial fractions that we're going to get. So remember, you're going to be adding all those exponents on the outside of the parentheses. So we already got 2 here, and there is the 1 there. So 2 plus 1, we're going to have 3. So bust out 3 partial fractions. Now, here's the thing. What goes on the first denominator would be the first copy of x plus 1. So here you're going to have x plus 1 because look, x plus 1 is repeated twice, right? So first repetition will be x plus 1, and then second repetition will be x plus 1 squared. This is just the rule. And then the other one is just going to be just good old x minus 3. Okay, now let's deal with what goes on the top. Alright, so x plus 1, that's degree 1. So what goes on the top is the general form of the polynomial of 1 degree less than degree 1. So that will be degree 0, which is a constant. So I'm just going to write here as a. Now, let's look at the second one. You got an x plus 1 whole quantity squared, but that's nothing but a second copy of x plus 1. So on the top, be careful here. Yes, you're right. If I multiplied x plus 1 whole quantity squared, your degree is going to be 2. However, you don't care about that. The second copy would have exactly the same form on the top as what you put for the first factor. So if you put constant a over x plus 1, then x plus 1 squared has the same exact form, which will be just a constant. So it's going to be b. And then x minus 3, 1 degree less is constant, so that will be c. Okay, so let's just check it. I'm going to make something up, and then let's do this one together. So suppose I have x plus 1 to the third, x minus 3, and then x plus 4 to the, I don't know, maybe 2. All right, so first let's determine how many partial fractions that we're going to get. So there's 3 plus 1 plus 2. What the heck is that? 6. So we're going to have 6 partial fractions. Dang it, I'm running out of room. All right, so let's do this. So let's deal with x plus 1 to the third. So x plus 1 repeats 3 times, right? So first, you're going to have the first copy of x plus 1, second copy of x plus 1 squared, and the third copy of x plus 1, which is x plus 1 whole quantity to the third power. All right, now let's go with x minus 3. That's just only one factor, so you're going to have x minus 3. Now x plus 4 repeats twice. So the first repetition is x plus 4. And the second repetition is going to be x plus 4 squared. Alright, so hopefully you can kind of get the hang of it. Now let's go with the numerator. Okay, so the second copy, third copy, fourth copy, fifth copy, they're all going to have the same form as the first copy of the numerator. Okay, so above x plus 1, 1 degree less is a constant, so I'm going to have a b. Now x plus 1 to the second power is still going to have the same form because that's just a second copy of x plus 1. So we're going to have b, c, x minus 3, d, a, b, c, d, okay, e, and then f, just like that. Alright, let's look at case 3. Denominator has non-repeated quadratic factor. Quadratic means degree of 2. So I'm just going to make something up. So let's go with a little example. Suppose I have x minus 2 all over x squared plus 3 to the third. And then maybe x squared plus 1. Oh, you know what? Let me just erase that 3 because that will be repeated quadratic factor here. So let me just go with nice and easy first. All right, so let's look at that. So again, how many numbers of fractions are we going to get is you just count the outer exponents. Here's 1 and 1, so we're going to have 2 fractions. Okay, now what goes on the first fraction is x squared plus 3. And then x squared plus 1. Okay, so now let's deal with what goes on top. Now, what goes on the top is the general form of the polynomial of 1 degree less than what you see in the denominator. Did you catch me on that one? So what goes on the top is the general form of the polynomial of 1 degree less than 2. because you're given x to the second. So remember what the general form of the polynomial of degree 2 and degree 1 look like. So degree 1 is going to look like ax plus b. That would be the first degree general form of the first degree polynomial. So here, what goes on the top is going to be ax plus b. Okay, so that will be that since you're given the x squared on the bottom, you better have 1 degree less on the top. Now, same thing for x squared plus 1. The general form of the polynomial of 1 degree less than 2 will be degree 1. So here, pick a different letter though. And then here you're going to have cx plus d. Alright, so let's do another one till you get hang of it. So that's called the example right there. So let's go with x plus 3 all over, maybe let's go x squared plus 3 x squared. I can't do minus 1 because that means we could still factor that. So here you're gonna have, let's just do that. And then you know what? I'm just gonna add in this, x plus 2. Alright, so how many fractions are we gonna get? So we're gonna have 1, 1, 1. So for sure we're gonna have 3. So bust out 3 fraction bars. 1, 2, and a 3. Alright, so what goes on the bottom is x squared plus 3 because x squared plus 3 doesn't repeat. And then here you're gonna have x squared plus 1 and then x plus 2. Alright, so now let's look at what goes on the numerator. What goes on the numerator is the general form of the polynomial of 1 degree less than degree 2 because you're given degree 2 on the bottom. So that will be ax plus b. Same thing for the next one, cx plus d. And what about x plus 2? That guy is degree 1, so what goes on the top is the general form of the polynomial of 1 degree less than degree 1. That will be a constant. A, B, C, D, E. I can never do this. Alright, so here we go. Okay, now let's look at another one. I'm going to twist it around a little bit. So let's go with another example. I'm going to make it kind of look similar. Alright, so let's go with x squared plus 3, x squared plus 2, and then let's go with x minus 2 to the third. What the heck? Let's just look at that. Okay. Feel free to pause the video and determine how many fractions that you're going to get and what goes on the top. But anyways, let's determine the number of fractions that we're going to have. So we have 1 plus 1, that's 2. 2 plus 3, what is that, 5? So we're going to have 5 partial fractions. So okay. So now let's deal with the denominator. So x squared plus 3 only has 1 copy of it. So you're going to have just x squared plus 3. X squared plus 2, the exponent is 1. So means we only have 1 copy. And then let's go with x minus 2 to the third. That will be just like case 2. So you have 3 copies of x minus 2's now. So the first copy will be just x minus 2. Next, x minus 2 squared. Next, x minus 2 to the third. Alright, now let's deal with what goes on the top. Okay, so the first one, x squared plus 3 on the bottom, 1 degree less is degree 1. So here you're going to have ax plus b. Same thing, x squared plus 2 is degree 2. So what goes on the top is degree 1. So you're going to have cx plus d. Alright, now let's go with x minus 2. That guy's degree 1. So what goes on the top is just a constant term. And the other x minus 2 squared and x minus 2 to the third, they're going to follow the same exact format as the first copy of x minus 2. So here you're going to have a, B, C, D, E, F, and then just the g, just a constant. Alright, case 4. The denominator has repeated quadratic factor. Okay, so the best way to do it by the example, so let's take a look. So I'm going to make it similar. So x minus 2 all over, let's go with x squared plus 3 to the second and then x squared plus 1 to the third. Yeah, why not? Let's just stop right there. Okay, so how many fractions are we going to get? You got 2 plus 3, that's 5. So we're going to have 5 partial fractions. Always separate it with the plus sign. Okay, so ready? We're going to pretty much do the same thing as case 2. The only difference is that here, case 4, the denominator, the degree is 2 now, not degree 1. That's all. Okay, so let's follow the same way. X squared plus 3 has 2 copies of it. So first, we're going to have x squared plus 3. That's the first copy of it. And then you're going to have x squared plus 3 to the second. Okay, now x squared plus 1 repeats 3 times. So first repetition, second repetition, and the third repetition, just like that. All right, so now let's see what goes on the top. Hopefully you guys are kind of getting the hang of it. So first one, you got x squared plus 3, so 1 degree less is degree 1, so you're going to have ax plus b. Now the second copy, you're going to have the same exact form as the first copy. So here you're going to have cx plus d. Now let's go with x squared plus 1. So again, that's 1 less will be degree 1. So you're going to have ex plus f. Now the second copy and third copy is going to have exactly the same form as the first copy. So you're going to have gx plus h. We're pretty much going to run out of letter pretty soon. And then the third copy, a, b, c, d, e, f, g, h, I. It doesn't matter what letter you pick. Okay, I, and then I'm just going to do it like that. All right. So that will be case 4. Now, let's just to check your understanding. Let me just mix a lot of things up a little bit. So in summary, so let's just look at like maybe x plus 2 to the second. Numerator doesn't matter, by the way. So here, I'm going to go x minus 5 to the third, x squared plus 3 to the second, and you know what? I'm just going to bust this one up. X to the third plus 2. Yeah, I busted out the third degree. All right, so let's take a look at that one. Okay, now how many partial fractions are we going to get? You have 3 plus 2 plus 1. So that's 6. All right, so ready? What goes on under the first fraction is the first copy of x minus 5, because x minus 5 repeats 3 times, right? So you're going to have x minus 5, second repetition, third repetition. Okay, now let's go with x squared plus 3. That guy repeats twice. So first one, and then second repetition is going to be that. And then the last one is just x to the third plus 2. Okay, now let's determine what goes on top. So first one is x minus 5. So constant goes on top. Second copy, third copy, what the heck? I think my smoke detector is going off. Hold on. Okay, I'm back, and my house is not on fire, so that's a good thing. And if the smoke detector thing goes off again, I'm just going to completely ignore it. I'm just going to keep going. All right, so what the heck were we doing? Oh, yes, numerator. All right, so first we determine the constant a, and then second copy, third copy, they're going to follow the same format as the first copy. So here you're going to have b, c. Now let's go with x squared plus 3. So what goes on top is 1 degree less, so that will be dx plus f. And the second copy of x squared plus 3, it's going to follow the same format as the first copy of x squared plus 3. So you're going to have gx plus h or something like that. Now let's look at x to the third plus 2. So I just threw that one in there and see if you can see the pattern or not. Okay, so notice that the bottom degree is 3. So what you need to put on the top is the general form of the polynomial of 1 degree less than degree 3. That will be degree 2. So what we need to put here is a, b, c, d, e, f, g, h, ix squared plus jx and then plus k. So that would be like the worst case scenario. So I'm hoping that you guys are understanding at least how to decompose the given expression into partial fraction decomposition. But if you have any questions, please let me know.